So as you guys know, Sierra Circuits has been doing webinars for a while, and we're happy to talk about EMC, which is a challenge in the industry. And as technology trends are, moving in this direction, it's an important topic to really understand. And so Sierra, two words about Sierra Circuits. We are a quick cycle time, high technology PCB manufacturer and a PCB assembler. And then we also have supply chain logistics, and we do everything in the Bay Area today. So we're ITAR registered and mil-spec certified and AS9100. So that's pretty much what our business is today. And so we welcome any requests for quotes. So this is the table of contents for today. So basically, first and foremost, when you're designing any board, you need to pick your materials that are appropriate for your application. And in this case, we recommend picking materials, or I would say avoid materials with inconsistent decay, because that could cause impedance mismatches, which could result in EMI. And high CTE laminates also you should avoid, because they could undergo dimensional changes with the temperature shifts. And that we have seen lots of root cause failures because of CTE mismatches, both from PCB and assembly point of view. And you should also avoid substrates with high DF, which might introduce greater insertion loss and EM radiation. So just the opposite of what you should avoid is what you should do. You should pick materials, like Isola has great materials, FR408HR. HR stands for high rel, and the I-speed and the tachyon. These are all readily available materials with decays less than 4. And knowing that your material you're paying a little bit extra for material. If you have a very high-tech board, it's really not that big of a cost, but you're going to get a lot of benefit in terms of performance and reducing any kind of issues, with EMI and EMC. And so other material choices are the Rogers, the Itera MT40, Megtron 6, and also the EMC material vendor is starting to manufacture in the United States. So that's good to have choices when you're picking the materials. Also consider low profile copper to minimize conductor and insertion losses. And you want to select basically substrate materials that with high volume resistivity to minimize leakage currents and energy loss at high frequencies. So that's what you should consider when selecting your materials. And we have a material selector on our website, which lets you quickly compare materials and their properties so you can right size the material to your application and your manufacturing strategy. Some quick stack up suggestions which will help you in this journey is to place signal layers 1 dielectric away from the reference planes to enhance noise suppression. You want to maintain symmetry in your stack up. So you need to look at your via structures if you have any sublaminations, and that would determine, are you maintaining a symmetry? And you should provide at least 3 mils of dielectric spacing between signals and powers and ground layers to maintain good signal performance and reduce any kind of crosstalk or EMI. You can group signal layers based on their operating frequencies. And in a quick example, our design team isolated 2.4 gigahertz RF signals and 100 megahertz digital signal in one of their previous designs that they did. To know that you're getting your stack up close to right, we have a stack up tool on our website, which is very popular. And so if you haven't checked it out, I would do that. And we're consistently improving it, and I'll pass it to